Friends, in the previous class we are discussing the electrical properties of the solid, which electrical property of the solid which vary greatly from 10 to the power 7 ohm inverse meter inverse to 10 to the power minus 20 ohm inverse meter inverse. On the basis of the electrical conductivity or the electrical property, the solids are categorized into three types. That is the conductor, the insulator and the semiconductor. We know the conductors are those solids which have the conductance ranging between 10 to the power 7 to 10 to the power 4 ohm inverse meter inverse. To the next, semiconductors are those solids whose conductivity ranges from 10 to the power 4 ohm inverse meter inverse to 10 to the power minus 6 ohm inverse meter inverse. The semiconductor, they have low conductivity, or we can say they are non-conductor at normal temperature but becomes more conductor at increasing temperature. The next we will discuss about the insulator, that their conductivity ranges from 10 to the power minus 10 ohm inverse meter inverse to 10 to the power minus 20 ohm inverse meter inverse. This is all about the classification of solids according to its electrical property as conductor, insulator and semiconductor. Let us know it. It means we are discussing the semiconductor. Or let us know on the basis of electrical property, solids are categorized into what? Conductor, the next one insulator, or you can say semiconductor, and the next one is insulator. Conductors, those solids whose conductivity ranges from 10 to the power 7 ohm inverse meter inverse to 10 to the power 4 ohm inverse meter inverse. These are termed as conductors. In case of semiconductor, those solids whose conductivity ranges from 10 to the power 4 ohm inverse meter inverse to 10 to the power minus 6 ohm inverse meter inverse. These are termed as semiconductor. To the next, we will discuss insulator. It means those solids whose conductivity conductivity ranges from 10 to the power minus 10 ohm inverse meter inverse to 10 to the power 20 minus 20 ohm inverse meter inverse. What we know? Based on the electrical property, the solids are categorized into conductor, semiconductor, and insulator. The conductor, their conductivity ranges from 10 to the power 7 ohm inverse meter inverse to 10 to the power 4 ohm inverse meter inverse. They are good conductor. In case of semiconductor, their conductivity is intermediate between insulator and conductor. To the next, insulator, these are the poor conductor. We know, in case of solid state, it means conductor can be categorized into two types. One conductor, it conducts the electricity in solid state. For example, in case of metal, they conduct electricity in solid state because of presence of only electrons, free electrons. It means metal conduct electricity in solid state because they contain free electrons, and therefore it is termed as electronic conductance. But there are certain substances, there are certain solids which conducts the electricity in molten or in liquid state, that is in the form of aqueous solution, that is termed as electrolyte. It contains the free electrons together with ions. It means based on the type of conductance in their state, they can be categorized into two types. That is conductance in solid state and conductance in the form of electrolyte. What we know? We know metals conduct electricity. Metals conduct electricity in solid state because it contains free electron. The next one, there are certain solids, free electron, and it is termed as electronic conductors. The next, some solids are there which conducts electricity in molten or aqueous state. Because of presence of free electrons and ions. Clear? They are termed as electrolytes. It means what we know. Metal conduct electricity in solid state as well as in molten state. Because it contains free electron and it is termed as electronic conductance. But some solids are there which conduct electricity in only molten or aqueous state because of presence of free electrons and ion. They are termed as because of formation of or production of free electrons and ions. They are termed as electrolyte. What we know? We know iron is in solid state, copper is in solid state. They are metal, they are conductor. Because they contain free electron and free electron acts as a charge carrier and they are conductor in solid together with in liquid state. But when we are discussing about the sodium chloride, then sodium chloride contain ions, but that ions are not free to move in solid state. Therefore, it is acting as non-conductor in solid state. Whereas, when we dissolve this sodium chloride, solid sodium chloride, into water or when we melt it, on both the conditions the ions are free, and when ions are free, then they will conduct electricity. It means those substances which conduct electricity in fused state, molten state or in liquid states are termed as electrolyte. They are conductor because of presence of free electron. We will discuss the metal, that the conductance of the metals are dependent upon the valence electron. It means if a metal is there and it has more valence electron, then it will be a good conductor. We know the atomic orbital of the metal undergoes formation of molecular orbital. Molecular orbital which are termed as band. If a metal has partially filled valence band, if a metal has partially filled valence band which overlap with the higher energy band, unoccupied band, then in that case they have good electrical conductance due to presence of electron. To the next, let us discuss the electrical conductivity of metal or conductor, non-conductor, that is insulator, poor conductor together with the semiconductor by the use of band diagram. In case of conductor, what we see, this one is conductance band and this one is valence band. This one is conduction. It means the metals are conductor in solid state as well as in molten state. This is so because they contain free electrons. The conductance of the metal depends upon the number of valence electron. We know the atomic orbital undergoes formation of molecular orbital, and when the energy gap between the molecular orbital is least or when they are going to overlap and we have partially filled valence electron, then in that case the metal have good conductivity and electrons can move freely on application of electric field, therefore they are termed as conductor. It means what we are discussing, the case of metal. What we have, the first point, metals are good conductor in solid as well as in molten state. The next is that the electrical conductivity of metal depends upon the number of valence electrons. The electrical conductivity depends upon the number of valence electrons. The third point, the atomic orbital of the metal undergoes formation of molecular orbital, and when the molecular orbital are close to each other, and when the lower occupied molecular orbital overlap with the higher unoccupied molecular orbital, then application of electrical field, the electrons can freely move and therefore they are conductors. This one is lower occupied molecular orbital, and this one is unoccupied higher molecular orbital. We see that there is overlap. They have overlapping. Then in that case, on application of electrical fields, the electrons move from valence band to conduction band and they will conduct electricity. Therefore, they are termed as conductors. The electrical conductivity depends upon the number of valence electrons. The atomic orbital of metal undergoes formation of molecular orbital, which are close in energy with each other and forms band. The lower unoccupied, partially occupied band overlap with higher unoccupied band, higher unoccupied conduction band, conduction band. Then on application of electrical field, the electrons, they conduct electricity. What do you mean? It means in case of metals, we know they are conductor in solid as well as in liquid state. Why it is so? Let us discuss. We know the electrical properties depend upon the number of ions or the number of electrons. It means greater the number of valence electron, a good conductor, a metal is. To the next, we know the atomic orbital of metal undergoes formation of molecular orbital. And when molecular orbital, it means when they are close in energy, they form bands. Which band? This one is valence band and this one is conduction band. When the partially occupied valence band overlap with the empty conduction band, then in that case, on application of electrical field, the electron moves and conduct electricity. Therefore, they are termed as conductor. To the next, we will discuss insulator. In case of insulator, there is large difference between the conduction band and the valence band. Then at normal temperatures, they have only conductance, poor conductance, due to presence of electrons in only the conductance band. It means in case of insulator, insulator, this one is conduction band. This one is valence band. And this one is conduction band. What we see, there is a large energy difference. Therefore, in case of insulator, what we see,